solve absolute value equations. So obviously absolute value equations have absolute value signs in them, and just like every equation that you've had to solve before, the objective is to figure out which number or numbers fit into this x position right here, such that the left-hand side equals the right-hand side. Okay, and there's two main ways to solve them. One's by graphing, which I'll show you first, and then we'll barely ever use it because it takes quite a bit of work. And then the second one is algebraically, and if you haven't figured it out by now, almost always algebra is a little bit faster, probably a little bit easier, and in our school system we tend to focus a lot on algebra, probably too much. But anyway, let's get going by solving this graphically. So what I want is the left-hand side to equal the right-hand side. So what I could do is I could make the left-hand side, just make it equal to y. So just say y is equal to the absolute value sign, or absolute value of 2x minus 4. Now, if the left-hand side is equal to the right-hand side, and we've said that y is equal to the absolute value of 2x minus 4, do you see that it makes sense that y must also be equal to 2? Right? Since those two things are equal to each other, then they would both be equal to y if one of them is equal to y. Okay, the reason we've done this is because now we have these two in a form that we could graph both of these. So let's graph the bottom one first, y equals 2. So if you forget how to graph that, just think of all the points that have a y value of 2. This has a y value of 2, that's 0, 2. This is 1, 2. This is 2, 2, 3, 2, negative 4, 2. Oh yeah, now I remember. Well, actually I always knew. But if it's y equals something, it's just a horizontal line. So this is the line y equals 2. Guess I could label it y equals 2. Okay, now we're going to graph this up here, y equals the absolute value of 2x minus 4. But remember, to graph that, how we're going to start is by just graphing it without the absolute value signs. We're going to graph y equals 2x minus 4. Well, that's great because that's in slope-intercept form. It has a y-intercept of negative 4 and has a slope of 2, or 2 over 1, right? That's the slope, 2 over 1. So up 2, 1, 2 over 1, up 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 2 over 1. That's probably good. I guess I could go down. What the heck? Down 2 over 1, down 2 over 1, down 2 over 1. Wow, I've done a lot of points. Now, be careful, or take a second here. You actually don't want to join all of these together. Why not? Because we actually want to graph the absolute value of that. And remember, wherever you have an x-intercept, that's a critical point. This is where the graph is going to change direction. So this is all going to be exactly the same. This is going to go up like this. But instead of continuing down here, what happens? It makes that V shape, remember? Why? Because this point here has a y value of negative 2. But you can't have any negative values here. You can't have, y can't be negative because this whole side's in the absolute value. So the absolute value of negative 2 is positive 2. The absolute value of negative 4 is positive 4. The absolute value of negative 6 is positive 6. The absolute value of negative 8 is positive 8. And I guess that goes there. And now we can join this together. There we go. Okay? And why do we do all this? How do we know where the answers are? Well, you remember how to solve graphically. What you're looking for is where they touch, and where they touch or where they intersect is right there and right there. These are the solutions. So what exactly are the solutions? Well, we're looking for what x is equal to. So even though this point here is 1, 2, this point right here, 1, 2, we're only interested in the x value. So the x value is 1. One answer is x equals 1. This point here, the point is 1, 2, 3, 2, but we're only interested in the x value again, so the answer is 3. There you go, there's your answers. Not convinced? Think that was kind of strange how that worked? Let's see if it worked. Let's put 1 into here and see if it works. 2 times 1 is 2, take away 4 is negative 2, but then we have to take the absolute value of negative 2, which is 2. So that works. Let's try putting 3 in here. 2 times 3 is 6, take away 4 is 2, and the absolute value of positive 2 is still positive 2. Both of these work. It's good. Alright, as I said, that took a little bit of time, but maybe it'll help you see why you often get 2 answers. Because when we go down here, you're also going to see that we often get 2 answers. Not always, but often. So we're going to solve these algebraically. For the first one, I just want you to think about what the answer is, or could be. You should be able to do this. If the absolute value of some number equals 10, what is the number inside the absolute value sign? Well, hopefully you get that it could be 10. But what other number could it be? X could also be negative 10, because then when you take the absolute value of it, it would actually become positive 10. So there's two answers here, and as you saw up here, there's often two answers, not always. Okay, great. Now, can you see how you can do something similar over here? This bit inside the absolute value signs, the x minus 3. What could the x minus 3 be equal to? It could be equal to 7. But what else could the x minus 3 be equal to? It could also be equal to negative 7. How come? Because if this amount in here, this x minus 3 amount, if that amount in there is equal to negative 7, then once I take the absolute value of it, it would be equal to positive 7, and that's what we want it to be equal to. So now that I have two equations, we're just going to solve them both. In this one, we're going to add 3 to both sides. So you get x equals 10. In this one, we're also going to add 3 to both sides. But this time, you get x equals negative 4. So we have our answers. However, you must check them for extraneous solutions, extraneous roots. It's possible that it's actually not an answer. So let's try. 10 minus 3 is 7, and the square root of 7 is 7. So this one worked. How about this one? Negative 4 take away 3 is negative 7, and the square root of negative 7 is positive 7. They both worked. So these are both good answers. So the steps, what are we doing here? Well, the first thing we're doing is we're going to isolate the absolute values. We didn't have to worry about this here. It's already isolated, but we'll see in some other questions you have to isolate it first. The second thing is you're going to write two equations. So you see how for one equation here, we just kept it exactly the same, x equals 10. But in the second equation, we made it x equals negative 10. We made this bit over here, we made it negative. Same here. One equation was just x minus 3 equals 7. We made nothing different. We just ignored the absolute value signs. The other one, we kept this side the same, x minus 3, but we made it negative 7. So that's what I mean by make one negative. It's not very good notes. If someone came and read this, they probably wouldn't understand it, but hopefully you understand from looking at the examples. Step 3, solve both the equations like we did, and step 4, you must check for the extraneous solutions. Alright, that's it. That's the whole lesson. Now we're just going to do a bunch of more examples and we're finished. So, step 1, make sure your absolute value signs are isolated, and they are. There's nothing else on the left-hand side. Step 2, write your two equations. So one equation is going to be exactly the way it looks. Just ignore the absolute value signs. So that's one equation. The other equation, it's again going to be 2x minus 5, but this time we're going to make this whole right-hand side, we're going to make it negative. So negative all of this. Okay, now you're going to solve both of these. To solve these ones, I'd move the negative 3x over, or put plus 3x and plus 3x. I like to do that to keep my x's positive. You could also go minus 2x and minus 2x, but I don't like doing that. So I get 5x minus 5 equals 5. Add 5 to both sides. You get 5x equals 10. Divide by 5 on both sides. You get x equals 2. There's one answer, or potential answer. On this one, 2x minus 5 equals, so this negative, it's like negative 1, negative 5, and negative 3x is plus 3x. Okay, this time I'm going to take away 2x, because that'll keep my x's positive. Remember, I always move the one that's smaller. 2 is less than 3, so I did like that. So I end up with just x here, or 1x. So negative 5 equals negative 5 plus x. Add 5 to both sides. That's 0 equals x, or x equals 0. Okay, before we go on, you got to check this. So let's try this x equals 2. 2 times 2 is 4, and 4 take away 5 is negative 1, and the absolute value of negative 1 is positive 1. So I'll just write that there. That's what we have to get on this side too. 3 times 2 is 6, and 5 take away 6 is negative 1. Hey, wait a minute, it didn't work. This is an extraneous solution. So you got to reject that. You could put extraneous, or you could just put reject, whatever you want. Okay, let's try 0. So let me get rid of this first. Let's try 0 in here. 2 times 0 is 0. Take away 5 is negative 5. And the absolute value of negative 5 is positive 5. If I put 0 in here, 3 times 0 is 0. And 5 take away 0 is 5. Yay, it worked. So this is actually our only solution. Okay, more of the same here. Well, there's one extra step. We have to isolate the absolute value signs, and it's not isolated right now. We also have a plus 12 on this side. Pretty easy to deal with that though. What do? Just take away 12 on both sides, then you'll have the absolute value sign isolated, equals negative 3. Okay, make your two equations. One's going to be exactly the way it looks, 3x minus 4 equals negative 3. The other one's going to be exactly the same on the left-hand side, but it's going to be negative 3. Yeah, whatever's on the right hand side, you'll just put negative of that amount. Okay, solve this one. Oh, by the way, you should be able to solve this if you really understand absolute values. You should be able to tell me the answer to this question right here. If you look very carefully at what this equation is right here, you should be able to tell me what the answer is right now. You don't even need to do this step here, any more of the steps. You don't have to do it. Take a second, see if you can figure that out. If you can't, then keep going. You'll still get the right answer. So I need to add 4 to both sides. I get 3x equals 1, divide by 3 on both sides, x equals 1/3. Over here, I get 3x minus 4 equals negative 3 is positive 3. So I add 4 to both sides, 3x equals 7. Divide by 3 on both sides, x equals 7/3. Hope your algebra is pretty good because I'm going pretty fast there. Alright, and then you would have to check these. So, a little bit tougher to check. If I go put the 1/3 in there, I get 3 times a third. 3 1/3 equals a whole, equals 1. So 1 take away 4 is negative 3. The absolute value of negative 3 is positive 3. And positive 3 plus 12 is 15. Whoops, that didn't work. So this one is rejected. Okay, let's try this one. 3 times 7/3. You know how to do that? You should. I shouldn't be doing this. 3 is the same as 3/1. You can ninja slice this and get rid of the 3's, so you're just left with 7. So 3 times 7/3 is 7. 7 take away 4 is 3. The absolute value of 3 is still 3, and 3 plus 12 is 15 again. This one didn't work either. They're both rejected. Too bad. The answer to this is that, no solution. Okay, how come you could have told me this answer right here? Because look, you're taking the absolute value of some amount and you're getting a negative 3. Can you take the absolute value of something and get a negative amount? No, absolute values by definition make it all positive. So you should have known right here, if you really understand absolute values, that the answer is no solution. And think of all the time we would have saved. So watch for that sort of thing. Okay, last one. A little bit different, a little bit more difficult because you have a quadratic here. Still follow the same steps. Isolate the absolute value signs. It's already isolated. So write your two equations. One's 2x squared plus 7x minus 1 equals 3. Just keep it all the same. The other one's 2x squared plus 7x minus 1 equals negative 3. Make that other part not in the absolute value sign, make it negative. Okay, we got to solve quadratics. To solve quadratics, you got to make it equal to 0. So we like how this is positive, the 2x squared. So let's move the 3 over. So minus 3 and minus 3. You get take away 4 equals 0. And now we have to factor. Try to take out a Grace-Count factor and you can't do it. We need to do Bobby Bridge. So you're looking for two numbers that multiply to 8 and subtract to 7. That's 8 and 1. So we've got 2x squared. We're going to decompose this. Plus 8x. Take away 1x, take away 4 equals 0. Now we pair them up. So we get 2x is the greatest common factor in the first ones, and x plus 4. I see a negative sign. 1's the greatest common factor, and x plus 4, because negative 1 times positive 4 equals negative 4 equals 0. It worked. We got x plus 4 in both of them. We also have a 2x minus 1 equals 0. Using the zero product property, you get this. Imagine at the start of the year if I'd gone this fast with the factoring, you would have freaked out. But now you should be able to do it this fast almost. So x equals negative 4, or if you can't do this, plus 1, you get 2x equals 1, divide by 2, x equals 1/2. So we have two possible answers, negative 4 and 1/2. Why don't we check them right now? Let's do that. So if I take negative 4 and put in here, I get, you got to do the squaring first. Don't go 2 times negative 4. You go negative 4 squared, which is positive 16, times 2 is 32. 7 times negative 4 is negative 28, and then take away 1. So 32 plus negative 28 is 4. Take away another one is 3, and the absolute value of positive 3 is still positive 3. This worked. Let's try 1/2, a little bit more difficult. Okay, 1/2 squared is a quarter. 2 times a quarter is 2 quarters, or a half. So this is a half. 7 times a half is 7 halves. And then take away 1. 1/2 plus 7/2 is 8 halves. And 8 halves is the same as 4. And 4 take away 1 is 3. And the absolute value of 3 is 3. It worked. Yay. Are we finished? No, we're only halfway done. We still have to solve this one. Ay, ay, ay. So we try to do the same thing. We need to get it equal to 0. So 2x squared plus 7x. This time we're adding 3 to both sides. Negative 1 plus 3 is plus 2 equals 0. You try to take out a greatest common factor, you can't. Bobby Bridge. You're looking for two numbers that add or multiply to 4 and add to 7. Multiply to 4, those are the only two options, and add to 7. Huh? There is no such numbers. So is that it? Actually, it isn't. X equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. That's what we have to do now. Oh my goodness. So x equals negative b, which is negative 7, plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is also 2, all divided by 2 times a, which is 2. So x equals negative 7 plus or minus the square root. 7 squared is 49 minus 4 times 2 times 2. That's 4 times 2 is 8 times another 2 is 16. All divided by 2 times 2, which is 4. X equals negative 7 plus or minus the square root of 33. All divided by 4. Make sure that line gets all the way over there. Can you simplify 33? 3 and 11, and that's it. No pair. So that's it. You're done. You can't simplify this anymore. So you're done. But you know what you'd actually have to do now? You would actually have to try this. You'd have to check this in here. Can you imagine? First of all, how many answers is this? This is 2 answers. One's plus, one's minus. I would have to put negative 7 plus root 33 over 4 in here and in here, and then see if it works. And then I'd have to do negative 7 minus root 33 over 4 in here and see if that one works too. If you were going to do that, I would recommend that you actually turn them into decimals first and do it. But I tell you what, if I was to put one of these questions on a test, you'd only be able to do like one question on the test. It would take so long. So if you get some crazy quadratic formula sort of answer like this, do the following. Circle it and put check it yourself, Waj. And then you don't have to worry about it. It just takes too much time. But you must write check it yourself or now check it or something like that, so I know that you would have at least thought of checking it. Okay, if you want to go ahead and check that, I'm going to leave that for you. I don't want to do that right now. Alright, that's it. I hope that makes sense, and have fun solving these absolute value equations.
When the music's over, turn up the lights, turn up the lights.